into the contrast to the previous presentation, I will not be sharing any equations. It's more like empirical systems, and also this will be more like how to make a little simple self-driving car without spending a fortune on it, especially if it's a hobby. So this is one of the most important things. So let's start it. First of all, this is a adjusted presentation by the first, which was created by Ed Murphy, and he was presenting this at October 2019. So that presentation is different. I've just updated it with some stuff, and also I'm doing this with his permission. And okay, let's go. Let's start. So first of all, what is the DonkeyCar? And this is actually a project, and this is a project created in a Python library, and it was also created to make a fast experiments and make it easy to contribute for the people, and it's more like a hello world for the self-driving cars. It's open source, and you can go to the website, and also there's a repos on the GitHub. Also, it's possible to use it directly and fork it. There's many different projects. And currently the community is on the Slack. I'm going to share this presentation later. And also right now they are moving to the Discord because of the limits of the communication number of the messages on the Slack. So, who is the DonkeyCar? Actually, it was created by two guys, Adam Conway and Will Roscoe. Right now there are more than 4 committers, but there are 4 main committers. Tom Kramer is a lead project maintainer right now. Also, there's a company that was doing stuff related to it, like cars, parts, and so on. So it's more like a bigger community. So first of all, why should you be interested in this car? Why should you be interested in this project? Well, let's start maybe from the grounds that, first of all, how it was with me. When I was a little boy, I always wanted to have a self-driving remote control car. Well, maybe not self-driving, but just a remote car. And recently, because I'm just a system admin and doing automation stuff in the cloud, I decided, hey, how about getting stuff related to the machine learning, AI, and so on. So when I once noticed that this is the project that it actually exists, I really was not able to sleep all night long, because I said, this is it. Looks like a perfect toy for me to experiment. And yes, this is not a toy for kids. It's more like a toy for 16 plus, at least, because it's really more complex than it looks like. And at least it's not that expensive than the typical cars. I'm gonna cover this in the next slides, so you're gonna get more stuff. So in general, if you're, for example, a guy that is doing stuff with the racing cars and you're bored with that, or for example, you have a 3D printer or laser cutter, it's really not required, but if you really actually like to tinker around, so why not? And maybe you're a programmer. Maybe you would like to know more about TensorFlow or Keras and so on. Maybe you would like to learn more about Linux and how to do stuff on for example, Raspberry Pi on different platforms. This may be for you. And of course, machine learning and data science, if you get into this and you would like to start from the very simple things, then why not to just use the video and doing stuff with TensorFlow to learn how it works. It's really easy to start. There's a huge amount of things. So first of all, what do I need to get started with the project? And let's say that we don't have full free time every day, and most of us are working normally, maybe not in the self-driving cars and some super extra technology. So I have some constraints, and I decided, okay, I can, let's say, do this stuff in the weekends. So after looking back to the history, it took me about 40 hours to get it up and running. And it's really from the complete scratch, from zero, about knowing no idea about the self-driving cars, or general RC cars, how to do stuff with Raspberry Pi, how to do stuff with the TensorFlow, and how to connect all this stuff. So actually, it's really more like reading from the start and then knowing what's going on, waiting for the parts, because, for example, buying them from the out-of-shore companies, and also then merging them, installing software. So actually, when you want to start this, you have to answer the question, do you have enough time for this? Is it really worth for it? You should read, of course, this presentation and the documentation. There's a huge amount of more detail in there. And you can start even from the beginning with just a PC computer and just to learn how to install stuff and run the program. Second thing is electric RC car. This is something like that. It's going to be covered later. This is, you need actually a remote control car. It has two parts with this related. Also onboard computer to later on control how to steer it. And you, of course, this project is limited mainly to the camera, video camera. So this is on the front of the car. And it's wide-angle camera, so it looks down to the road and tries to detect where the trucks is, but actually it doesn't really care about the trucks if it's not trained well. And next is the parts like a chassis. So this is where do you place the electronics, and you place it on the car. Next is a wireless controller. It's not on the in here, but it's more towards make it much easier to ride around the open spaces, because you can also use the web controller, but it's slow. And the last thing is instructions. It's very well documented, comparing to other open source projects. And the core, the heart of the project is the pure code in the Python to run it and mix it with something else. So okay, so as you can see, it's really complex, and it's gonna be not that easy as it looks on the screen. And some things may be pretty different than you are expected to be. So first of all, some acronyms, because some of you may not be really from the RC background or the automation, so it's complete zero. And some of these acronyms are from the self-driving cars, some is from computing, and different stuff is from remote control cars. So let's start with the most commonly used, ESC, electronic speed control. This is for controlling the engine. Next is I2C. This is inter-integrated circuit bus. And this is used for sending signals from the onboard computer to the engine. And using PWM, pulse width modulation. This is a very specific, but it's really not important. So this is the most important acronyms you will see in this presentation. So let's start with the host, so normal computer who would like to be prepared. So usually you already have this. This can be a laptop, so you can actually run even the basic models on this. It's just gonna, you don't have to have a dedicated NVIDIA GPU, and it's just gonna take some time, more time to compute. For example, if you have a 5,000 images, it's gonna take 1.5 hours. So it's with GPU, it's gonna be like 5 minutes or less. So if you really need to iterate faster, you can, for example, do this on dedicated hardware. About the GPU, I strongly suggest to read the documents about the TensorFlow, because it's used in the project, and there are some recommendations about what kind of graphic cards to use. Long story short, keep to the NVIDIA 1060 or higher, or the recent RTX. I have no idea about the AMD GPUs. If you don't have this kind of hardware, you can But if you, for example, have access to the cloud resources, you can create a virtual machine. Of course, you have to request for the GPU from the cloud provider, and then really learn how to turn on and turn off the device, because you pay as you use it, even if it's doing completely nothing, you have to pay it. But if you do it well, then you can, for example, train multiple models for the price of the cheeseburger. Okay, so the software required on the hardware. It starts from Ubuntu Linux, because mainly this is required by the TensorFlow. You can do this with different operating systems, but it's gonna be more problematic. And of course, you can run it on Windows 7 or newer. I've been using this on Windows without issues. I know that some people are working on Mac OS X and have no idea about the version they're using. Optional NVIDIA CUDA software for offloading the computing to the GPU. And next, the RC car. So what do you need is to get this kind of stuff like this. This is a little car. It's very important to say that the size matters, because this one is 1 to 16, and there are bigger ones. The 1 to 10 is a very big one, and there are even 1 to 5, but they are more like a little driving trucks like this. And next, it really depends on what do you get, because the chassis defines what kind of plane you can place on the top because of the distance. Also remember that different cars have a distance, different dimensions, so it's gonna be a slightly problematic. You can just move these parts around. And also, if you're going in the future, looking into the future to the racing cars, remember that most of the racing cars are only for electric cars, because you can get cars which are using alcohol or something like that. But they are much noisier, and also most of the races are done in the closed rooms. Let's say something like that. Also, you don't really have to buy everything from the start. If you think that you need it, just wait. You're gonna feel when it's really actually ready to get it, when you think that you're gonna benefit from this. About the pricing of the car, in general, you can buy already the RC car without RC controller. You don't have to use the remote controller, and then it's gonna be much cheaper. The car itself is something about 80 USDs. The whole project, let's say from the beginning to the end, with the computers, batteries, and so on, it should be less than $400. It's even with higher margin and with transporting costs. Also remember to get the battery and dedicated charger to the battery, because sometimes you buy a car without battery and it's gonna be a problem, especially that some companies cannot send you a car with battery across the border or the oceans. So remember that and write down if you can get it. Okay, so let's say we have a car, then what's next? The next thing is onboard computer. So this is gonna be like a Raspberry Pi. It was created on the Raspberry Pi. You need at least 1 GB of memory. It's more like a convenience for computing stuff. And also you can use a Raspberry Pi number 4. It's just gonna be slightly warmer, but at least it's much more powerful. If you are going to be more interested in doing real serious stuff in real time, you probably will be interested in getting the NVIDIA Jetson Nano. It can offload the computing power to the GPU on its own, although it's much more expensive and requires additional tools like a dedicated network card and so on. So it really depends. Also, remember when you are using operating system to use the Raspbian Buster. This is the latest operating system from Raspberry Pi, and I guess it's also for Jetson Nano. Why not Stretch? Because Stretch is quite old one, and also upgrading to the Buster takes so much time, so it's really easier and faster and quicker to just make fresh install. About micro SD cards for the system, 22 gigabytes is good enough. You just get decent card, like probably like $20 or less, probably less. It just makes things faster, and you will not have to wait for some certain things. Most of the computing is actually just CPU, and writing data to the disk is not that problematic. You could actually even stream it to the different location. Okay, so next, additional hardware you would like to get. For example, in my car, I have one battery that is powering the engines and servo mechanism, and also Raspberry Pi. So I need a step-down voltage regulator. So the battery is 7.2 volts, and Raspberry Pi is 5 volts, so you have to just convert it. Next is motor controller. So this is a little board that is used to control the engines. It's something like a $5. The step-down controller is also about $7. Next is cables. If you are having any kind of basic setup for the Raspberry Pi, like startup or Arduino, it's gonna be like $10 or even less. You don't really have to use so many cables. Something about 20 is good enough. Also, the next thing required is chassis, so you can place it on the car itself. And also this triangle where you're placing the camera. Actually, this is gonna be, because it's a 3D printed, it's gonna be quite expensive, so you can try to find alternatives, or even it's so simple that you should be able to do it with different tools. Extra tool is wireless game controller. Right now there is a support for Xbox One, PS3, or actually PS4 is better, and Logitech. And it really makes easier for steering the car, because you can control it over the web, but it's going to be a latency problem between the time it takes to catch the video, process it, send it to the web page, and you watch it on the laptop and then steer it back, and just it takes enough time to process it, and you will notice there is a latency issue. And if you can, for example, control the car directly, it's just much more easier. Okay, so we have this kind of hardware. It's time to, yeah, it's a joke because of the serverless. Let's assemble this, because right now we have required parts, and what do we need for the car? So this is a typical car without the top. So we can see it's steering angles. There's a servos for steering, engine, DC motor for keeping the car up and running back and forth. ESC, so it's just controlling from PWM to the engine, and also it's for steering and going throttle up and down. There's a little gears just to change the speed of the engine to the wheels. Receiver. So as I said previously, you don't really have to use the remote control receiver. You just need device to send signal, PWM signal from the Raspberry Pi. So for example, I bought this from the Hong Kong, and actually there is no remote control, so I had to actually get how to get this up and running over the web, and then get the Xbox controller. I really don't need a remote control right now, because it's not needed. I could just use it, but whatever. And one of the most important things is battery. A lot of people are wondering, how do we connect this to the system? And remember that depending on the models in this picture, you have this little green connector, and there are 3 or 5 standards. Most common one are Tamiya and XT60, or yeah, something like that. And depending on the battery, for example, LiPo batteries are much more They require more power, so or better cabling. So you're gonna have a requirement for example, to change the connectors. Okay, so let's say we have an electric remote control car. This is a basic model. It does not show you the connection of the power. Let's say that in here, and in here there would be special connectors to the battery and just to keep it up and running. Sometimes the electronic speed controller is sending directly on different link electricity to the DC motor, and then it's gonna be called BEC, integrated with electronic speed controller, ESC. So usually you don't have to think about this because it's up and running and ready. You just have to care about the connectors and make sure that you check if the battery you get is properly aligned with the connector, because sometimes I know that people were getting the batteries for the airsoft guns, so it's a different game, but they tend to have these connectors swapped, and the people are burning the electricity, the electronic devices. So watch this and better make sure that it's working as expected. So let's say that we have in previous slide we have a remote controller. So it sends the signal over wireless to the RF receiver. We don't have this one, but it's very important because, as you can see, there's a pulse width modulation. So what is this? This is actually just controlling the pulse of the signal. And depending on the size of the signal, there's information what to do with the engine. So for example, this is a 0. So the engine, let's say that the steering is in the middle. Go left, go right. And same thing, something similar is with the going forward and back. There's also, you don't really have to think about it because it's already solved in the software. So what are we going to do is to replace the radio receiver with our electronic device. And what can we use for that? So one of them is to use the little servo board. I have this on my model, or we can just use Arduino. So this is a completely different story. Or if we have this, we can use directly pins on the board, but it's really quite complex, and it's cheaper and easier to make it with the first solution. So we're gonna have this RC and the receiver removed. That's why it's in red. Then we're gonna put the electronic PCA device in the same place, so it's actually just a replacement. Then we can just use the cables to connect our Raspberry Pi to the PCA. Actually, here is one cable, and from the PCA there are 2 cables, and we don't really need anything else. We don't need any more engines. Sometimes there are special cars that, for example, they don't have this kind of configuration, more like 2 DC motors, and they are steering like a tank. So, for example, you break one set of wheels and run the other, and actually you are running 2 engines, DC motors, without a servo. Okay, so next things, we have a Raspberry Pi. We would like to use something to remotely control the car. Then we can use gamepad, and because it's quite easy, we can use Bluetooth because why not? It's working, so this is the most common situation. We could try to use something else, but it really doesn't matter. With Bluetooth, it's very easy, secure, and fast enough for us to make it happen. Especially the game controllers give you a lot of keys to adjust special operations to the buttons. Okay, the last thing to set up is camera, so that our super little car can actually see where it's going. So this is an assembled car. As we can see, it has in here the camera mounted in a way that actually it's above the horizon. There are different, for example, I have a camera more towards the ground, because when you're getting too much stuff from above the horizon, you can catch too many things that you really are not interested for your AI. Of course, you can software limit the video but sometimes it's not worth it. For example, we will be interested more towards getting what's going on in front of you. Also, the one information worth to note, get the wide-angle camera. This way you can see more. Also, you really don't need to create any special video processing like remapping to the orthogonal systems or to straighten everything up, unless you really have to, because the modern the real cars are doing something like that. So we have this. So how about software? Now we are ready to get it up and running. So let's go back to the host PC. The software in the GitHub is adjusted to be installed by Miniconda. In here it's Python 3.7. On Raspberry Pi, I guess it was in 3.6. If I remember correctly, 3.5 is still supported, but it's more like a going backwards. The code was probably more like a 3.7.5 because of the limits of the P camera. I'm not sure if the 3.8 is ready. Probably no one ever tried this. Although we can use Anaconda or PyEnv, depending on what are you doing. Then you can test more solutions or be more elastic to solve your own problems, for example, different setups. And in general, Python 2.7 probably is not supported at all, not to mention that Python official 2 is officially already dead, and you should really do stuff in Python 3. Next, optionally, you can install TensorFlow GPU for NVIDIA cards. I know that how to do this on Windows, Linux. No idea how about Mac OS X. In general, it takes about 2 hours, mainly because of the downloading drivers from the internet and then installing this stuff all together. For example, installing from scratch on the virtual machine takes about 40 minutes in the Google Cloud. It's just a long-running process, nothing else. After that, you can, for example, have this as a working environment. You can create an image in the cloud, or well, you could try also to use the virtual machine on your computer and then directly attach the GPU, but that might be more complex than actually you would need it. Next, install software on the car itself, on Raspberry Pi. So first of all, you need to flash the SD card. There is a tool, or the whole documentation presents you with this information, and Balena Etcher is used for copying the image, and this is the moment when you really want to have a fast SD card. Next, you just have to set up the Raspberry Pi. There are some tools or even distributions already prepared for DonkeyCar with pre-configured system. apt-get to install packages is gonna take some time, especially if your system is old. Virtualenv OpenCV is gonna take a few minutes. Then cloning the repo and installing dependencies is gonna take another 20 minutes. And then finally, DonkeyCar create card in given path. It just creates a skeleton of the project, and it's like a hello world ready to work, ready to operate on the basic setup. So you really don't have to touch anything, and it's worth to note, try not to configure it and try not to optimize it, because it's already done by the multiple people and it works. And read carefully about the comments in the code, because the config is in Python, but it's very easy to configure. Just make sure to remove the spaces, because the Python is very specific about this. Remember also to enable the, with RSP config, enable to I2C to control the engines and camera. You don't have to run video, so like you don't have to use the X Windows system to manage Raspberry Pi. You can just remote SSH remotely to the host and just run it without even watching and connecting the HDMI cable. So when we have a working software, it's worth to make a snapshot of the card, because if you're gonna lose it, it's gonna take some time, or if you're gonna break it. Remember also to safely turn on and turn off the Raspberry Pi, because of the you can just if you have a not good enough power source, you can trash the SD card and you have to create everything from scratch. So make a backups. Next thing is very important is to calibrate the car. When you look on the vehicle, there are some special little metallic tubes that you can turn and adjust the steering wheels. Next, it's more like adjusting the car from from the original setup, so that it drives somewhat forwards in a straight direction. Don't try to adjust it when it goes backwards, because it's usually gonna be going left or right. Next, you can steer the wheels outside to make it steer more to the given direction. For example, my car steers more towards right angle. Next, there's a calibrate command to run the software with Python script. Then you can connect to the PCA device, and it's very well documented about how to do it, what's going on, and it's gonna give you the limits for steering left, right, and forward and backward. You have to do it only once for given chassis, and sometimes you cannot copy-paste the config between the different cars. So remember that. Also, you can limit the maximum speed of the car. So, for example, you don't hit the walls immediately. This takes about, well, I've written 30 minutes, but actually you can do it in 10 minutes if everything works. But this is the moment when you actually have to test all the cables and see what's going on. So next, driving. What do we need for driving? First of all, double check the connectivity. First of all, check if the battery is not too low, because otherwise it's gonna be a very sad moment for you. Power cables, sometimes those little connectors are getting loose, so it's a problem. If you are using the wireless controller, remember to check the batteries and Bluetooth. Also remember about the obstacles between you and the car. For example, the fridges at home are really very good at blocking the wireless or Bluetooth signals. Remember the protection cap from the camera. A lot of people are wondering what's going on. I cannot see anything because you didn't remove this one little guy, and you have a blackness on your screen. So it's very funny. And of course, if you have other devices, double check them. Most of them have some kind of LED displays or LED diodes that just blink or glow when they are up and running. Next is system check. Usually it's not a problem because power device is good enough. Free storage is not a problem. You probably need something like 5 megabytes. More important is actually getting all the useless stuff from the system. That's why, because the CPU usage is very important, and also memory. That's why I said that if you're installing Buster Raspbian system, keep the light version, because you don't have all this stuff lying on and running in the background. It just takes some resources. Next, start software, and immediately you will see if the camera is up and running, steering, if it's working. Sometimes, for example, I'm by accident hitting the buttons and they switch the operation of the car. Next, this is a very important thing, because when you create a car for the first time, you have to learn how to drive it. If you have never used the remote control car, it's very edgy in situation, because, for example, you're not used to the controlling. Also, you can limit the maximum speed so that you actually not gonna break anything. Once even damage the camera. That's why it's little curve in here just to protect the camera. Some systems even have bumpers in front or in the back just to limit the amount of damage that is possible. Also, if you have a LiPo battery, remember to protect it because LiPo batteries are very explosive and very dangerous. And that's why I have NiMH battery. It's just safer, although it gives less power. And also maybe in the future gonna make a upgrade. Next, there are some custom controllers like Xbox One and something like that, and you can, for example, change the axis because, for example, some people prefer to have a throttle on the left hand and steering on the right. Sometimes it's swapped, so it's gonna take some time. In general, when you're gonna drain battery like 3 or 4 times, you are ready to ride without problems. Also take note how much does it take to recharge the battery, because you can plan your work and, for example, do reading between the charging. Also, you can, for example, charge and keep the Raspberry Pi up and running if you connect properly cables. Okay, so the next idea is how to actually learn our car to drive. So the process is like that first we ride with the car, we record the video, or actually the pictures of every 20 Hertz. And also it writes the files with the information, what was the throttle, what was the steering, and other inputs, for example, accelerometer if you have that one. Then, when you stop the recording, we can send the data to the host PC. Then we can configure, for example, more precise things we would like to do, for example, computing. Like how many times we'd like to run the simulations and so on. Also the cleaning up the images, like for example, we don't have to record or learn our DonkeyCar how to drive because we just started to drive. We would like to learn it how to drive around the space. Also, you really don't need to have a dedicated track, because let's say we have a space like in here. If the car can fit in these locations, we can learn it to ride around in here without any special things, because this is the way the TensorFlow works. The image processing is very powerful, because actually some videos show that people were learning cars in this kind of open spaces, and actually I'm gonna tell more about this. The cars was driving actually watching the lamps on the ceiling and not on the floor itself. Next, the most important thing is removing missing data, because it's gonna break the computing. Of course, it's automatic, so it's not a problem, but just have to remember it. Also, there's quite important information about the model we would like to use when we are training, because there are different ways to drive. I'm gonna talk about this later. Okay, so next we're gonna try to train the model. We're gonna run the Python script, and it's gonna use the CPU or just GPU and process it. It's gonna take some time. Next, we can see what's going on with our model, like render images, see, for example, the TensorFlow results, or even render video to see what parts of the image were actually affecting the driving. So, for example, you can learn that your fridge is more important for the car than, for example, lines on the floor. Next, adjusting the config file if required. At least some people are doing the problem, the error that they learn driving in 30%, and then the model is trained to get about 60% of the accuracy. So actually 60% of 20% is very low, and the engine is just has not enough power to even steer to drive the car. There is one configuration place that you can just set up throttle, and it's usually very easy to set up and You just set it once and forget it, and it's working. Next, you upload your training model to the car. The model itself is something about 20 megabytes or even less, depending on the image resolution and stuff inside. And finally, you're gonna run the script again on the car itself and with the model. This way we can switch between the driving modes, like from user perspective, then to the mode when the car is only steering left-right, so that we can, for example, control the throttle, and full auto mode when it's going up, forward, tries to be as fast as possible. Of course, repeat these steps to get different models, different data, tune it, and so on. So, about the data we are getting, the basic model is a behavioral cloning. In the previous presentation, there was information how to drive the car, and one of them was try to mimic the real driver. So you actually learn how to drive, and after setting up the car in the same spot and learning it, it's gonna just copy your movements. Of course, there are some special recommendations how to drive to learn the car in those special edge cases. And this is a completely different topic for another setup, but it really helps you to get it up and running very easily. In general, you have to have three inputs: image, steering, and throttle, and the frequency, how often it was recorded. Because of the limits of the computing power on Raspberry Pi, it's set up on 20 times per second. It's good enough. Some hardware, like overclocking the CPU or getting different hardware, can get you to 60 CPU hertz or even 100 in very edgy situations. Of course, these faster speeds are required if you would like to get faster movement on the tracks. And data collected is really very small. It's like 20 megabytes, but the problem is that it's a huge amount of files. Like Windows has problems with the directories that are having like 10,000 files. It's gonna be much slower. Linux doesn't have this kind of problems, or OS X. So remember that. Try not to record too many images. You don't really need this. Next, when you start the car, this is a web UI. There's information on what port it's working. And in here, you can see there's a joystick, gamepad, or device tilt control. So you can use the joystick directly, like actually this part in here. It's really problematic to use it. And that's why most of people are suggested to use the gamepad, because the gamepad is directly connected to the device. It's much better. Also, you can use the device tilt. So, for example, you have a smartphone and connect it to the I guess Chrome web browser. You can use the phone to steer the car up and left, right, up and down, and control it. But it really requires some experiments. Throttle mode controls how the car is going. So, for example, you can create a user or predefined setups. This is a very good one to limit the maximum speed, so that, for example, you're not hitting the walls immediately. And in here, the real information shows you what's going on when you're driving. And this is one of the most important things, that what's happening when you change this. In multi-user, you are controlling the car, so you're going forward, backward, and steering. There is a mode. Oh, sorry, I don't remember. But one mode is that the car is using the model trained, and it's gonna be steering left, right, and you just control the speed on your own. So that, for example, the car is gonna be, without your control, it's gonna be standing and trying to switch the wheels, but not moving the forward. And the last one is full automatic driving, so it goes up, forward, and tries to ride. Also, if someone wonders why it's named DonkeyCar, this is the great moment because the car itself behaves like a stupid little donkey. It tries. The idea is to keep it running in the circle or a closed path, and it's just gonna be doing all this driving and nothing else. So it's not super complex. It's completely different story. It's more like a line. There are some self-driving cars that know how to drive over the white lines. But although you can try to use different models to see what's going on. Okay, so the driving data we have. So those are two examples. Like the picture taken is very blurry. Actually, it's even more. It's much smaller, and you have to get used to it when you are driving. Next is the steering handle, throttle, information, what kind of source it is, user mode, and timestamp. This can be, because these are the JSON files directly on the disk, you can process it with the different tools. I don't know, probably send it to different map, for example, matplotlib or something like that, and get something more interesting. Next, of course, we are not perfect drivers, so we can run the tools for cleaning unwanted stuff. You can do it manually or run the web server that you can select the images and delete them. Remember that this really saves time for computing in the future. And of course, if you really don't have a car, or you would like to try to run the Donkey even without hardware, you can try to use the Donkey simulator. This is a Unity engine system, and it renders this is a 3D model. All the 3D scene and everything is rendered in the Unity engine, and this is actually just mimicking the real driving. Of course, right now I know that Tone is making a remake of this and changing the model that you can actually spawn one single server and train even 4 cars at once. And it increases the training speed tremendously. Also, this really saves you from buying the car in the first place if you, for example, have some hardware and to see what's going on. Also, this is very useful to test if your car is actually driving as you expected. Also, there are some special libraries or prepared models and textures to simulate different surfaces so that your car can drive in different conditions. Okay, so, oh, maybe this one. This is a full screen. Of course, I didn't have time to test this, maybe the next week, but it looks promising. I know that more and more people are using this. Even some serious companies are using that for training. Also remember that it's pretty important to adjust some modifications so that the steering is not so perfectly balanced, because otherwise you're gonna hit very interesting problems in the future. After that, I'm gonna maybe talk about this later. So now, training an autopilot. So we have all this data we gathered, and we would like to train our super Terminator that's gonna kill us while driving the car. Is it? Well, not really. First of all, we have to train this on the PC. We can train some called tabs, so these are packets, directories with the images and the JSON files. And we can put one or multiple ones. So for example, depending on the party, we can create, for example, different setups. And the model we would like to produce. And of course, we have a TensorFlow. We can use it on GPU. It's going to be just way faster. Remember that number of files and images is actually limiting or deciding how many computing power you require. And actually, the most important one is memory. You try not to hit the swap or page file on the Windows. there is a special settings in the config to limit this. Of course, it's going to be slower, but then we can create huge data sets and test this. I know that some people are using Google Colab, but I guess there are some compatibility issues. I'm not sure if they are fixed right now. Also, you really don't need the GPU. It's just going to take some time. Also, enabling GPU is going to be much faster, but the complexity of installing the software sometimes is problematic, especially that CUDA 10.1 or 10.2 is just sometimes consuming. Okay, next, when we train an autopilot, we have different models. I don't know about TF-Lite or TensorRT models. Probably if someone is using different hardware, is going to use this. Or Google Coral Edge TPU. I know that some people from Google are using the DonkeyCars to experiment. Remember that the default model is a regression model, and you can expand it. There's a web page about the different models. For example, there's a behavioral one, so you can learn the car driving on different lanes, or for example, learn to do different stuff depending on the conditions, like going left when there's a green light, going right when there's a red light, and so on. Next, there are some augmentation tools to adjust the images, because if your images are too perfect, then your model is going to be too perfect and it's going to fail in very strange conditions. You can crop the images, and this is very important because it limits the computing power and makes stuff faster. But remember to keep all this configuration in sync, otherwise you're going to have strange errors that the image input is different than the model, and it's going to crash, and you're going to think about what's going on. Next, the transfer learning is very useful because you can already use the same model multiple times and feed it with different data and get it better and better. So for example, you have 20 different tracks on 20 different setups, and you can train the model and create a perfect one, which is going to write in given conditions. I know that people are using this one to experiment with different tracks, especially when they have a cloudy weather or super sunny, and so on. So this is a model loss. If you are in the machine learning stuff, you will use this. Long story short, there is some document on Google about what's going on in here. Of course, I'm not going to explain this, but the main issue in here is like the axes are not zeroed properly, so sometimes aligning the images takes some time. I guess we're going to have to make a pull request to fix this. It's going to make some stuff much easier. Also, when you can change the model that you use. I know that Adam is default one, but you can use different ones, so get better models. Of course, there are some moments that you get the local minima, and you can see that your model sticks to specific behavior. So, about the checking if your autopilot is working. There's a very useful tool named Topplot that can render images that shows you what's going on the steering, how the model is behaving, reacting. CNN activations is very useful to see exactly what's going on in a given image. Also, there's missing one. You can actually render the video with the activations, so you can see what part of images or the tracks are making your model behave in that way and not the other. Also, there's some profiling scripts to see what's going on. So this is an top plot, so you can see how your user, the blue ones, are how the human was behaving, and the orange one is artificial intelligence, what's going on. And usually the AI is getting things slower or not very. It's not hitting the limits as the human would be doing. For example, people are usually when are driving, they're trying to hit maximum steering, and AI is usually in 80% of that. Okay, so this is about the activations. As we can see, there is a green line that shows what was actually what the human was doing, and the blue one is the model, what was AI predicting. The green dots in here shows that these are the most important parts for the image, and this is very important because you can learn that, for example, the reflections on the floor are super attractive for your DonkeyCar. So, for example, you have a very shiny floor and you have lights on. You start to learn to drive the car. It's working very, very nice. And someone goes in, switches the lights, and all the cars are hitting the walls because they are losing the very important part. So this is very important to analyze and to see what's going on. Okay, so actually our super terminator is actually more like a stupid floating, floated animal or floated balloon. So now we can, for example, you have a model, it's trained like 15 minutes, we copy it back to the car, we can run this command with these parameters, it's gonna run as normal, and then we can switch with the key or web interface the model, and we can see it's alive, like in Frankenstein movie, but although it's probably not gonna drive as it's expected. This is very interesting for some people, what's going on actually in the driving loop. So it detects if it should work with neural network. You will notice that when you activate the neural networks, the compute power will be noticeably higher. Requirements for the computing power will be noticeably higher. It's gonna drain battery faster, and the CPU is gonna be just 100% used. And then the most important thing is that actually the car itself in the basic model is just getting information of the given moment, like get the picture compared to the model, what was going on in this in the specific image, and then send, for example, steer right. And so send the signal to steer right to the wheels and to the controls. So it's more like react in this given moment. There are some special models that, for example, get the history of take last 5 images and processes if you can. Also, there are better tools to, for example, feed it with more data like gyro or accelerometer to get more detailed of what's going on with the car. Because sometimes when you have only video, you're not able to predict, for example, what's going on. You know that you are driving, but for example, you don't know how fast you are driving because the models are very simple. So that's all about the driving. And so what can we do with that? Because we have a working model, so if we are good enough, we can try to race. And actually there are some serious business racing stuff especially in Silicon Valley, if you are there. Otherwise, you should try to find something locally. I know that there's some racing in Finland and in Germany. Not sure about Poland. But still, we can try maybe something in Poland. Okay, so let's try to race it. The first, I hope, the real-time demo gods will be good, or maybe not. So this is probably what's gonna happen with your car on the first try. Oops. Oh. Nope. Let's try again. Without the sound, we don't need sound. So 3, 2, 1, let's drive. And yes, this is what happens. You hit the spot or you're driving in circles. So this is very common because your car is pretty dumb. For example, when you forget to remove the cap from the camera, this happens. Or for example, the car is completely going insane. Okay, so maybe something really better. If you tune or you gather more data, you're gonna get more information. And then when you start in a race, you're gonna turn properly. Or your car even can cheat and miss some turns, because why not? So, of course, one of the main challenges is to finish the race itself, at least one loop. The second is not to hit the cones and try not to hit the enemies or the opponents. So this is very specific. Of course, when you start to do things better, oh, sorry, the video is very strange. The best solution is to actually learn or use the very good data, like someone who is really very good at driving car itself. I have problems with clicking with mouse. Yes, it's very difficult for me. So yeah, this is an example of what's going on when you have a very good guy driving very fast. Notice how well this goes, and it really depends on the wheels, the model, train, the hardware, technology, and so on. And it's really nothing special. It's only just getting very detailed data. So guys from the machine learning, they say that the most important thing in these driving cars is just getting very good data and trying not to touch the model at all. You don't really need this, especially in the beginning. Okay, so what's going on when you would like to get into the driving? So these are the statistics about the drivings and in different technologies. So as we can see on the left, there is a time to finish the lap, like 30 seconds. And the yellow, this is the fastest human. I know that this right now is slightly lower. The idea is that this was getting real professional remote control driving guy to ride around the path, and he managed to squeeze the 7 seconds. Probably right now it's like something like 5.6. So as we can see, even after tuning the driving cars, they are as good as people, or sometimes when you have enough data, they are even better. So we should be very, very, sorry? Well, it depends. If you would like to be racing against the car, it's bad news. But if you would like to put this kind of technology into the car, it can save your life, because it's going to be faster. So what's next? Because we have a working car, we have a software, we can tinker with that, we can see what's going on, and is this the end? No, not really. Because you can learn from this. First of all, the best thing is that it's a really low price entry level, because the previous solutions were like thousands of dollars or even millions, or the whole teams. There was from Zurich, the team was like 15 people, and you can almost get almost the same technology on your own, doing it on your own. Of course, it's just a joke, but it can really make your experience easier to get to see how it works, much easier. The beauty of this is that the source code is open source. The documentation is pretty well defined. People are open, and it's very easy to get involved. Try to read over the internet. You don't have to read only about the car. There's a huge amount of people that are doing remote controlling cars. Some people are coming from the flying devices, and I know that they even trying to use the same model for flying autonomous drones. Of course, you can experiment with this, like learn new. I'm, for example, adding new sensors and doing some optimizations, like most like a controller to easy start and shut down the system and copy data more automatically. Also, there are some special reinforced learning projects that are using DonkeyCar. You can test with different stuff, just Google. Also remember that you can get pre-configured, easy to set up hardware. There are companies that are just created for this to make it easier. And they, for example, give you actually everything. You can buy everything from the car, the parts produced, and so on. And sometimes they have even configured to choose the parts depending on what you would like to get. Of course, start cheap, or at least maybe not super cheap, but try not to buy everything. But it's very good beginning, even for the universities. So what can you do with that? Of course, you can help people from other doing some different stuff with robotics to get involved. You can get. I know that there were some questions about using DonkeyCar in the universities, and there are even probably packs like 5 or 10 cars to just buy cheaper and train them with different stuff. Also, AWS Deep Racer was started as a DonkeyCar race. I don't have this kind of video, but they showed that they created their own hardware model. They created their own software on the AWS Web Console. They actually allowed you to train the model in the virtual environment and then transfer the model to the car. And there were so many spectacular failures because of the model was the 3D model was perfectly balanced while the car was very bumpy and it was more like going like that, and the camera was losing what's going on and had no idea how to handle this kind of misalignments. Main takeaways: if you have $400, you can get one. Even for 300, you could be setting up the car, especially in the United States. Then 8 hours is like getting up and running with assembling the car, software install and driving. Very important thing: no soldering is required, so you don't really have to use anything special. You just use the pre-configured connectors and it's working. It's just reusing the breadboards or electronics or prototyping related to Raspberry Pi or Arduino. Try not to start optimize from the start. I was talking about this, especially the camera, and it's very easy to extend it with different stuff like battery, additional sensors. You would like to be interested in getting maybe the additional extra cameras like stereo video or LiDAR, but LiDARs, so laser-based image processing is super expensive, but gives you fantastic solutions. The previous presentation was showing how awesome it was, but the price is very high. Of course, in the future, you can replace this with different car. And what next? I think the first very interesting thing is that you can focus on specific parts of the car, especially if you would like to create a team. So, for example, you have guys from the machine learning, they can tune the model. If you got someone that likes to get doing stuff manually, they can just create a car, optimize stuff and print and so on. You can have someone to integrate all this together to processes in the cloud, whatever you like. It's very easy to learn all the stuff in the process, so you can just benefit in learning. Okay, so that's all. I think the questions, if anyone has.